All right, so this is now the dividing of our complex numbers in polar form. So before when we did multiplication, it was you multiply and add the angles. And so with divide, you divide the radiuses and subtract the angles. It's very nice how math works that way. So order matters here though. So Z1 is on top, so R1 is going to go first and theta 1 will go first, and 2 is going second. But you're dividing the radiuses and subtracting the angles. And here is the reason why. So I've put the top one on the top and the bottom one on the bottom. We're going to use a little trick here, our difference of squares. And so we end up with this being multiplied. And then the I squared, it turns into a -1, right? And so that turns into a plus. And so cosine squared plus sine squared is 1. So that's gone because it'll just become R2. And on the top, we're do the same thing we did before, but this time we're using the difference identity for cosine and sine. So you'll see now it's a minus that turns into a plus. So that's a minus, that's a minus, so that's a minus. So we get this. All right, so let's try one. So all we have to do now is multiply or divide the angles. So we're going to get 4, and I'm going to put it in cis form, cis 45. That's on top. And on the bottom, it's 2 cis 90. And so this would end up giving us 2 cis 45 minus 90. So we divide the radius, as you can see that here, and we subtract the angles. It's really nice, right? Okay, so 45 minus 90 is -45. And again, I want to put it back into its 360. So if we add 360 to that, so you can even just go 45 minus 90, hit enter, plus 360 to give it its positive coterminal angle, 315. So 2 cis 315 degrees, and there you go. We've now divided it. So what if you say, oh, you want to put it back in its complex form? Okay, let's do that. So this would then become 2 cosine of 315 degrees plus I sine 315 degrees. And so that would then give us 2 parenthesis. So that's square root of 2 over 2, and that would be negative square root of 2 over 2. And let's verify that in our calculator. So cosine of 315.7, correct. And sine of 315, -0.7. So there's your rad 2 over 2 and negative rad 2 over 2. So it looks good. Distributing the 2, we get rad 2 minus I rad 2, and there is our rectangular form of our complex number. So that's it. Let's try another. So we're going to divide. So Z1 goes on top. So 7 cis 300 degrees over 14 cis 120. And again, we divide. So that would be 1/2 cis of 300 minus 120. So I was talking about order matters. Whatever's on top has to go first. So this is 1/2 cis, and then 300 minus 120 is 180 degrees. And there is our polar form. So putting it back in complex, we just do 1/2 cosine 180 plus I sine 180. And so cosine of 180 is -1, and this is 0. So we end up with just -1/2. So it is a real number. Let's check out with our calculator. So cosine of 180, there's our -1. Sine of 180, there's our 0. It checks perfectly, so we get -1/2. All right, why not? One more? Sounds good. This one's already in cis, and you notice there's no radius. So if there's no radius, we don't have to even worry about it. You just put cis 180 over cis 60. And so this would be cis of 180 minus 60. So it's cis of 120. That's it. And so checking this would be cosine of 120 minus sine of 120. So cosine of 120 is -1/2, and sine of 120 is rad 3 over 2. And then we put our I back in there, and there we go. That is our complex number. Again, we should check it. So cosine of 120, negative 1/2. And sine of 120, there's 0.86, so that's our rad 3 over 2. So it checks perfectly. So there you go. That is dividing complex numbers in polar form. All right, thank you.